All right, so what do you think speed is?
The velocity of that something moves in a certain time.
How fast something is going.
Right, it's pretty straightforward, right? How fast? When we talk about speed, we're talking about how fast an object's moving, right? So what do you think the units are of speed? Miles per hour is what we use for imperial, but how about metric? Kilometers per hour or meters per second. Cool? So that's what we're talking about speed. Does anybody know what the equation for speed is? Distance divided by? Nope.
No, distance divided by time.
Distance divided by time. Remember, distance is meters, time, seconds. Cool? Now velocity. Anyone know what velocity is?
The rate of which something travels.
The rate in which something travels?
Yeah.
It kind of is how
the
fast.
rate of speed. I guess.
But there's more to velocity than just simply how fast. It's how fast
How much we're moving.
in a direction.
Oh.
How fast is it moving in a specific direction? Okay? It's called speed with direction. Cool? That's velocity. So if it's speed with direction, what are the units of velocity?
Unit distance.
Speed with direction is a meters per second per direction, right? So it turns out the units for velocity are meters per second.
Meters per second.
Meters per second. Just like speed. The direction would be meters per second north, meters direction per second positive, meters per second negative. Cool? Yeah.
So when you say positive and negative, is that going up and down?
It could be meaning up and down. Typically, we think of motion going up as being positive and motion going down as being negative. It also could mean if I'm going this way, I can claim that that's positive, and me going backwards would be negative. It's just how you set up your orientation. Cool? But it gives me that direction with that positive or negative sign. That being said, what do you think the equation for velocity is? If speed is distance divided by time, what do you think velocity is? No? Anybody?
Distance divided by time.
Displacement
Alright, displacement.
divided by time, which is
Meters per
meters
second.
per second. It also is the change in position, which is another word for displacement, divided by time. All of those are definitions for velocity. Cool? So far, so good? So let's try something. Let's try an example problem. So imagine that I have a car that goes 20 meters in that direction in 5 seconds and goes 10 meters in this direction in 2 seconds. What's its speed? And what is its velocity? Cool. Just take a few minutes.
Just have a question.
Yeah.
So how far we just traveling those 20?
So how far it travels, its distance would be 20 and 10. That will give you its distance.
So are we traveling any longer than 5 seconds or just?
So we're traveling 5 seconds here and then 2 seconds here, so a total of 7 seconds. Okay? Take a few minutes, see if you guys can get an answer. I think it's you and you and you. So how far does it travel? 30 meters, right? So distance is 30 meters, and it does it in 7 seconds. That's its speed. You can leave it like that, I don't care. So the answer would be 30 divided by 7 meters per second. What about its velocity? So it goes 20 meters this way and 10 meters that way, right? So if it goes 20 meters that way and 10 meters that way, and its change in position, which means final position, x typically means position, minus initial position, divided by time. So its final position
Well, it's in the middle, 'cause
10 meters. And its initial position is 0 meters, and the time is 7 seconds. Okay? The other way you can look at it is how is its position changing? It goes at 20 meters, and then it loses 10 meters. So its total change is 10, divided by 7 seconds. Either way, you're going to get the same answer. That's going to give me 10, that's going to give me 10. So my velocity for this case is just going to be 10 divided by 7 meters per second. Cool? Does that make sense? Flip it. So instead, it goes 10 meters this way in 2 seconds, and goes 20 meters this way in 5 seconds. What's its speed and what's its velocity? Take a minute or two. It is for one of them, but not for the other. Distance. How much distance does it travel?
Wouldn't it be 0 because 10 is all the way down?
It goes 10 and then 20, right? It doesn't care about the direction, it's just caring how far it traveled. So its total distance is 30 meters.
I thought you couldn't go like... Oh.
You can't be negative. So this negative 20 meters is 20 meters. It doesn't care which direction. So that's why it's 30. And it does it in 7 seconds. So there's no difference here. The speed stays the same whether it goes 20 and 10 or 10 and 20. It doesn't make a difference. What does make a difference is the velocity. Okay? If you look at it, it goes 10 meters and then goes back 20 meters and does that in 7 seconds. So when I got the first one was 10 divided by 7, and this one I'm left with negative 10 over 7. And what that means is that for the first one, the net motion was this way. It was traveling in this direction. For the second one, the net motion is this way. It started here, ended up here. So it looks like it's traveling this way. Where the first one is it started here and ended up here. So it looked like it was traveling that way. So its velocity for the second motion is negative 10 divided by 7 meters per second. Does that make sense? Yeah? So that's what velocity is and that's what speed is. That's the difference between the two. Cool? All right? We've got one last term to go.